All right, so I'm assuming that we're good with complex numbers here. Like I say, not too tough. With complex numbers, just remember, what does I squared equal? -1, right? I squared equals -1. So when you multiply them together and you get that I squared, that's -1. That's how you simplify those, okay? All right, so with our starter question, what does absolute value mean?
It's point from zero.
Right, yeah, distance from zero, right? And what's unique about absolute value? It's always positive, right? Okay, good deal. Okay, so it's often helpful to draw pictures. Now, you really can't graph imaginary numbers on the XY plane because there's nothing for the imaginary part, okay? But, so we're gonna change the terms of our X, from an XY plane to what's called the complex plane. So on the complex plane, we have, the old Y-axis is the imaginary axis, and the X-axis is the real axis. Now, you may put them in terms of A and B, because like say complex numbers are always A plus BI. You could say this is the A-axis and this is the B-axis, if you will, as well, okay? All right. Now, we often use, and you'll see this a lot in this chapter, the letter Z to represent a complex number. So Z equals blah, or Z sub 1, Z sub 2, Z sub 3. Whenever you see that Z, that's a complex number, okay? All right, so if we were to graph the following on the complex plane, so we wanted to graph -2 minus 3i. So we'd go -2 in the real direction and -3 in the imaginary direction, and there's your point. That's point A. Okay, -5 plus I, so go again, -5 in the real direction and 1 in the imaginary direction. There's B, et cetera, et cetera. 4 minus 4i, down here somewhere, and square root of 3 plus I. Root 3 is what, 2 and some change? No, 1 and some change, almost 2. And up 1, so right there, give or take, is D. Okay, so those are just points. Now, the absolute value of a complex number, or you'll also hear it called the modulus, okay? So when you see, when you're asked to find the modulus of a number, complex number, it's just the absolute value, okay? And it just simply equals this. It's the square root of A squared plus B squared. Okay, so we ignore the I when you're finding the modulus of a complex number, okay? All right, so want to find the modulus of -2 minus 3i. That would just be the square root of -2 squared plus -3 squared, which gives us root 4 and root 9, so the square root of 13. Whoa. So in other words, if I graph the point -2 minus 3i, right here, okay, and I went from the origin to that point, guess what that distance is? Square root of 13, right? And so that's what that means. So it's also, when you say absolute value modulus, that's also the length from the origin to that point, okay? Bless you. Wow, times 2 or 3. Okay, so part B again, so it's the square root of root 3 squared plus 1 squared. So it gives us a square root of 4, which is 2. So again, if we go root 3 and 1, we decided about right there.
So you just changed the I to a 1?
Yeah, that's like 1i, right? And then again, that distance right there is 2. Yeah, so whenever you do the modulus and stuff, which we're going to actually do a lot, okay, in these next couple sections, you just drop the I, essentially. When we first did logarithms, I'm sure you're thinking, holy cow, this is just making this way more complicated, right? Putting things from exponential form to logarithm form, we're just like, there's, what's going on, okay? But then as we started working on things, you found out that they actually made impossible equations very easy to solve, right? And it's the same thing with complex numbers that we are going to put in trigonometric form, okay? You're gonna think, my gosh, that's just making this way more complicated. But as we start doing some more complicated math on this, you're gonna find that trig form makes life a lot easier. Okay? All right. So, now when we write a complex number in trig form, we do it by recognizing that each complex number can be located using the distance from 0 and an angle measured from what we call standard position. And we all know what standard position is, right? What is standard position? From, yeah, starting on the positive x-axis and then measuring that way. Taylor, you can grab that door. Bless you. Man, we got sneezies today. Okay, so we'll then use that angle and the modulus, okay, or the length, okay, to find the horizontal or the real and the vertical or imaginary components of the complex number. Okay, so by definition, if z is some complex number a plus bi, then the trig form of z is r cosine theta times I sine theta. That's the trig form of a complex number, where r is the modulus, okay, the square root of a squared plus b squared, and theta is an angle in standard position, okay, whose terminal side contains the point. Okay? All right, so sounds a lot more complicated than it is. All right. Okay, so let's convert these from standard form to trig form. Okay, so what we need is we need r and we need theta. Okay, so in this case, we've already done r for this point, correct? What is r? R is 2, right? Now, how do we find theta? What do you think? Give me some ideas. That's not very many ideas. Connor, grab the door book. I'm sorry, I've just told Alex here. Okay, if we graph it, right? Now, what can I form here from this? What kind of triangle? I can form a right triangle. So I know that my vertical component is 1 and my horizontal component is root 3. So now how do I find theta? Which sides do I know? I know opposite and adjacent. What's opposite over adjacent? Oh, so we're going to, theta is then the arctangent.
Could you just use your shoe and just do like the sign of like?
Well, yeah, in this case, yeah, that would also work. Yeah, you could use the sign as well, because we know that r is, we know that that one is 2. But in generally, Tanner, I'll tell you, just get used to using the arctangent, okay? Because then sometimes you're not going to need to find r, or r is screwy, right? So, and generally, not always, but generally they make it so your arctangent works out somewhat decently, okay? So we have the arctangent of 1 over root 3, which is, should be 30 degrees. Is it 30, right? Okay, it's 30 degrees, okay? Now, trig form can be in either radians or degrees, okay? So make sure you read the directions carefully to see what they're asking for. All right, so now we're ready to put this in trig form. So the trig form then is r, which is 2, times the cosine of 30 plus I sine 30. And there you go. Okay. Bless you. Times 2. Okay, and for anybody else that sneezes during my lecture, bless you. All right, now I'm covered. Okay. All right, so let's look at part B now. Let's put this in trig form, okay? So what is r? Okay, it's the square root of root 2 over 2 squared plus root 2 over 2 squared, which gives us, what's root 2 over 2 squared? 2 over 4, which is 1/2. So you get 1/2 plus 1/2 is 1. The square root of 1 is 1. It's always good when your modulus is 1. Makes life easy. Okay? Now what's theta? So theta is the arctangent of 1. Good. And so that is 45. Excellent. Okay. So then trig form is equals 1 times the cosine of 45, 45 plus I sine 45. All right, now an important note here, a little box, okay? There are lots of angles that would be coterminal with any theta we use, but we will normally want to choose the smallest positive angle, correct. Now, not always necessarily, okay, but normally you want to choose the smallest positive angle. Okay, so now if I have an angle in trig form and I want to put it in standard form, okay, what do? What do you think? Don't make this difficult, because it's really simple. So I'm going to get rid of my sine and cosine stuff, right? So why don't I just take the sine and cosine of my angle? So what's the cosine of pi over 4? Okay, pi over 4 is 45, correct. What's the cosine of 45?
Oh,
Root 2 over 2. So now I have 12 times root 2 over 2. And what's the sine of 45? That is also root 2 over 2. Okay, and now distribute your 12. So we get there's standard form right there. Like I said, don't make it hard. Just take the sine and cosine of the angle, distribute your modulus, and you're good. Okay, now this one, obviously we need calculators. Okay, so what's the cosine of 106 degrees? Ethan, you got that?
yep, negative 276.
Okay, negative 0.276. Okay. And what's the sine of 106 degrees? 0.961 I. And times each of those by 2.4. We're going to distribute our 2.4.
The first one's negative 0.662.
This one's 2.31.
Excellent. There's standard form right there for that. Okay? So going from trig form to standard form is like duh easy. Okay? Actually, from standard form to trig form is not too bad either, right? We just find r, square root of a squared plus b squared, and find theta, the inverse tangent of b over a, basically. Okay? All right, so far so good? Okay, so the next step here is if we want to multiply two complex numbers together, okay, or divide them, then here is the formula, okay? So if I want z1 plus z2, all right, that's just equal to r1, r2 times the cosine of theta 1 plus theta 2 plus I sine theta 1 plus theta 2, okay? Again, it sounds a lot more difficult than it is, okay? All right, so there's our two complex numbers in trig form, so we want to multiply those together. So in this case, we take 2 times 3 times the cosine of 150 plus 300 plus I sine. What's 150 plus 300? 450? All right, what's the cosine of 450? 450's coterminal with what angle?
Is it degrees or radians?
This one's in degrees. Okay, 450 is coterminal with what? With 90, right? So what's the cosine of 90? 0. What's the sine of 90? So what do we get? 6i. Okay. Now in part B, if we're dividing them, we divide our moduli. Moduluses is. We'll go moduli. Sounds cooler. So you get 5 over, now we subtract the angles. So what's pi 4 minus pi 6? Let's see, it's 12, 3 minus 2, so pi over 12. So 5 times the cosine of pi over 12 plus I sin, is that right? I sine pi over 12. Is pi over 12 right? Okay. All right, so now when you calculators, make sure you put them in radian mode. Don't leave them in degree mode. Cosine of pi 12ths. Oh, come on, you let me down, dude. I'm a calculator guy. Ethan, what we got?
0.966.
0.966. Okay, then what's the sine of pi 12ths?
0.259.
0.259, and that's an I. Now times them both by 5.
First one was 4.83. Next one,
1.29. There we go. Welcome to class. Okay. All right, so there we are in standard form. Now, if it says to leave it in trig form, then leave it just like that, right? We don't do anything with it, but generally it'll want you to put it in standard form. Okay, so now we're given two complex numbers in standard form, and we need to do the same thing. Okay. All right, so let's get them in trig form, and then we can use those formulas and go. Okay. So we know for Z1, oh my gosh, we know our modulus is 2. Okay, I'm still not writing this right. We know R1 is 2. Okay, and we know theta, we figured out theta. What was theta? The arctangent of 1 over root 3, so that's 30. Correct? All right, and then for Z2, so R2 then is the square root of 2 squared plus 2 root 3 squared. Okay, 2 squared is 4, 2 root 3 squared, 4, 3, 12, 16. Okay, good, that gives us a nice, easy, clean 4. Okay? And then theta is the arctangent of 2 root 3 over 2, or root 3. What's the arctangent of root 3? Make sure you're in degree mode.
60 degrees.
Actually, I'm going to say thank you. Actually, that's one that you guys should know. It's 60 degrees. Come on, people. We got to brush up on our unit circle. Okay, so now we want Z1 times Z2. Okay, so now we're ready. So we get Z1 times Z2 is, we multiply our moduli, 2 times 4, and we add our arguments. This is what it's called. That's how I always remember it. Okay, you multiply the moduli and you add the arguments. The angle, that's also called the argument. Anyway. Wow, I just went serious math geek on you. I apologize for that. Okay, so we get the cosine of 30 plus 60 plus I sine 30 plus 60. And again, what's the cosine of 90? 0. What's the sine of 90? So what do we got? 8i. Yeah, right on the stack back there, David. Thank you.
So whenever we get cosine 90 and sine 90, do we just add whatever the two are is multiplied by 2?
Yeah, times I. No, that's it. Yep.
Does horizontal mean perpendicular?
What's that? Orthogonal?
Yeah.
Yeah, it means perpendicular.
You think I mean, right?
Dude, come to class once in a while. It's amazing how that works. All right, Z1 over Z2 now. So now it's 2 over 4, and now we subtract them. So we get 30 minus 60, so we get the cosine of negative 30 plus I sine of negative 30. Okay, so it gives us 1/2 times, what's the cosine of negative 30? Root 3 over 2 plus sine of negative 30 should be negative 1/2. So yeah, let's make that a minus. Oh, we can make like that, plus a negative 1/2. Okay, distribute your 1/2, so we get root 3 over 4 minus 1/4. I. Oh, can't forget that I. Okay, so there is that division there. Okay. So once you get it in trig form, then performing operations on it becomes really simple. All right, so what would the conjugate of 5 plus 5i root 3 be? And the conjugate, again, is sometimes denoted as that, and we read that as z bar. So what's the conjugate of 5 plus 5i root 3? 5 minus 5i root 3, right? If we were doing like the normal type conjugates, okay? All right, now let's put these in trig form. So trig form then becomes, okay, so the trig form is z, so r is the square root of 5 squared plus 5 root 3 squared, which gives us 25, and then 25 times 3 is 75, oh, it's 100. Oh, that's nice. Square root of 100, which is 10. Okay, and then theta is the arctangent of 5 root 3 over 5, or the arctangent of root 3, which is, we're okay in degrees. Come on, people, 60 degrees. We just did it. So then the trig form is 10 times the cosine of 60 plus I sine 60. All right, now let's do the trig form of z bar. Okay, so r now is going to be the same. I hope you recognize that. R is 10. Now what is theta going to be? The arctangent of negative root 3, which is negative 30. Or negative 60, sorry. So the trig form then is 10 times the cosine of negative 60 plus I sine negative 60. So now, okay, in that form, we don't even have to look at or figure stuff out. If I put one number in trig form, then I just take the negative of theta. Notice r is the same. I take the negative of theta, and that gives you the conjugate. Okay. All right. So what is z times z bar in trig form? Okay. So let's see. So we get 10 times 10 times the cosine of 0 plus I sine of 0. What's the cosine of 0? 1. The sine of 0? So what do we get? 100. Okay. Where's our angle? Angle is 0, so which way does this go? Yeah, horizontally along the positive x-axis, right? Out 100 units, whatever that is. Okay. And then in standard form, oh yeah, so there's trig form, 100 cosine 0 plus I sine 0, and then standard form is just 100. All right, now the question is asked, does the answer in part D agree if we did the problem using a plus bi times a minus bi? So in other words, if I take 5 plus 5i root 3 times 5 minus 5i root 3, do I get the same answer? Let's see. So we're going to FOIL this, right? So 5 times 5 is 25. Now what happens to your outers and inners when you multiply conjugates together? They go away, right? So now I'm going to get minus 5i times 5i is 25i squared, and root 3 times root 3 is 3. What's I squared? Negative 1. 25 times 3 plus 25. Well, yah ha ha. They do work. Okay. So, trig form, standard form, pretty similar, right? So if you're asked, so let me ask you this, okay? So on MathXL, it gives you z and it gives you z bar, or it might even say, okay, what is the product of a complex number and its conjugate. What are you gonna put? What is it? Yeah, it's just simply r squared, right? If you take a complex number and multiply it by its conjugate, you're gonna get the modulus, or r squared. That's it, every time, okay? That's why we love conjugates, because stuff wipes out all the time. Good deal. All right. Is that it? I think that's it. Questions? No, okay? All right.